So next up, we will have Eric VanWinkle. I was asked by Jelani to take this on, so I'm not fully the expert on Eric's background, but I will give it a shot, and then maybe Eric can correct me if I didn't fully do him justice. So Eric VanWinkle is the head of operations and community at DeSci Labs. And he has previously been involved in Constitution DAO as a core member. Those of you who remember, Constitution DAO was a DAO that was trying to buy the American Constitution. I met Eric one time in Amsterdam when he was part of the organizing team for DeSci Amsterdam, where I think they did a great job. It was an amazing event where I met a lot of the interesting people that I'm still connected to in the DeSci space. And today, Eric is going to talk about Onchain publishing and credential to get connected to the work that they have been doing at DeSci Labs. So,
yeah, absolutely. Thank you, Jonathan. More than happy to. So just a heads up, I'm having some Zoom issues with my laptop at the moment. So I'm going to be trying to finish some of those in the background where hopefully by the time I make it to a point where I need slides, I can be back on. But in the meantime, I'm actually just going to quickly talk through some of the context and overview and maybe give a little bit of an overview on myself as well. But my name is Eric VanWinkle. I run operations for DeSci Labs. For those of you who may not have met us, DeSci Labs is a group that's working on the creation of PID infrastructure for research objects. So one of the things that we are incredibly passionate about is the idea that the scientific record itself is the center of human knowledge, and that the entirety of the scientific process should be captured within the scientific record. So at the moment, the only thing that you typically see in any kind of a publication is going to be the final manuscript, the PDF. If you're lucky, you'll see code and data. Although I will say that one tends to be more available on request than anything else. If you're incredibly lucky, you're going to see methods for a biological paper. You're going to see code that's been structured to be reproducible. There are ways that we can make the scientific record into a more complete and thorough representation of the scientific process itself. But we have a ways to go before we can actually make it there. And that is the focus of DeSci Labs. So we want to create a scientific record comprised of open and reproducible research. We want to make sure that any and everything which we create is done through open source software and is created as a part of open protocols. We want to make sure that interoperability and the FAIR principles are one of the basis of any of these creations, so that we're thinking about the future of machine actionable science as opposed to just the current paradigm of human-centric science. And then finally, we want to use some of the tooling that we've created to make scalable meta science infrastructure so that we can continue to experiment on the scientific record and the scientific process, or the scientific method, I suppose. One other thing that I'd like to point out before I really get started is the DeSci Foundation is a nonprofit arm of DeSci Labs. Actually, I believe they might be separate companies that hosts a series of seminars on a regular basis. We've had some great speakers. So the president of the Wolfram Institute came on at one point and gave a wonderful talk on cyborg scientists. We had George Church come on at one point, I believe. Great event. And for anyone who's curious, please, by all means, feel free to take a look into it. You can find more information at DeSciFoundation.org. But that being said, I'll get into, I'm going to go through three main sections in my presentation. The first one being context and background. So giving a little bit more of an understanding, which it seems like quite a few folks have already done throughout this larger talking or seminar series or event, but giving a broader overview of some of the exact problems in publishing itself. From there, I'll talk about how science is changing at a very high level and what needs to be done to actually look towards a solution. Then past that, I'll talk about the technology that DeSci Labs has made and some of the foundational components that we work on and why those matter and why they have benefits to individuals. And then I'll close out by talking about credentials on chain, because that's one of the more interesting aspects of blockchain, and that is actually the topic of this presentation. So I'll go through how we view pluralism, attestation, badging, and high-level credentials, both for organizations and for individuals. So with that being said, Ricardo, were the slides able to come through?
Yes, I have the slides, so I'll be sharing my screen. Hopefully you can all see it.
We can, and thank you for the audible here. So if we can start out with slide 2. Perfect, thank you. Actually, let's move to slide 3 if you don't mind. 4, because 3 is context and background. There we go. So the scientific record is the center of human knowledge. It is the point where everything is organized. It is the point where science itself can be referenced. And unfortunately, scientific publishing, the stewards of this particular record, have a series of broken processes and incentives that lead to a wide variety of problems. There are bad incentives on the scientific record, which incentivize novelty and to a certain extent sensationalism over robust, rigorous knowledge creation, which all stems from the impact factor itself. The unit of knowledge is obsolete. Large portions of infrastructure for scientific research were created in the early 1990s and haven't necessarily been updated since then. As such, the current journal and publishing system really only has a method of publishing solitary PDFs. There are a series of under-recognized efforts where you see a wide variety of people participating in the scientific enterprise, those who make data, those who make code, those who actually work behind the scenes to make to make research itself function smoothly, who just don't necessarily get recognized. If you're a researcher who has created an incredible data set, you can't accrue citations off of that, or it's significantly more difficult to do than accruing it off of a milestone paper itself. There are problems with fragmentation and link rot, loss of data, code, and artifacts, where if you're going to actually look for that information, it's a good chance that you're not going to be able to find some of the supplementary artifacts, which are crucial in reproducibility. We see the replication crisis. The president of Stanford University recently stepped down due to allegations coming from inside of the university about some of the methods for his research itself. And while that's still under investigation, that's just one of a million stories that continuously come out. And then finally, problematic business models. I know that this is one that Jessica just touched on, so I won't go too far into it, but scientific publishing itself is broken. If we can go to the next slide, Ricardo. The current infrastructure of science functions as follows. You start off by minting a PID, creating metadata in Dublin Core that would be stored with Crossreffer DataSite, where that information and the PDF associated go into a data silo structured around JAST XML, and finally into the landing page for a journal itself. This is a series of problems in a lot of ways because persistence for this infrastructure relies very heavily on social contracts. Once again, technology from the early 1990s that isn't structured for the internet of the 2020s and the 2030s. As you have the landing page, one great example would be the landing pages for journals and the fact that they don't necessarily resolve to the actual content that's being requested. So if you're a researcher and you want to go and see a PDF, you have to navigate to the journal's landing page, find the PDF, open that, and then find the information that you want. And as a human, that's not necessarily terrible, but as we look at some of the advances in artificial intelligence, we can start to see that humans and machines are going to have to work together to expedite scientific progress into the future. That's going to be the most efficient way to move forward. And thus, we need information to be organized in a way where that can happen. Ricardo, if we can go to the next. So fortunately though, we do have infrastructure that's old. We do have incentives that are wrong, but we have a rare moment in time right now whenever change actually can happen. So the diagram that you're looking at is the Center for Open Science's theory of change. And it basically says that we need change to occur along all 5 different levels of what they view the scientific enterprise as. So starting at policy, then going to incentives, communities, UI, UX, and finally infrastructure itself. And for us to see change, we need both top-down change and bottom-up change happening simultaneously. And we've actually gotten quite a bit of top-down policy that's been coming out. The Nelson Memo rocked the world of academic publishing, in the middle of last year by saying information needs to be open upon publication and data needs to be published with code itself. And actually targeting funding agencies as opposed to targeting individual researchers is a very interesting way to go about that. We've seen the FAIR principles take hold in a big way over in Europe, especially with the formation of the European Open Science Cloud and some of the FAIR for EOSC initiatives that have been there. They really help to put a focus on the importance of data publishing and open access. Ricardo? We also see bottom-up movement, where it's not just policy itself, but it's a look at infrastructure. It's a look at UI, UX, communities, and incentives. I mean, especially within the DeSci community, we see so many of these different things being worked on a regular basis. People are developing apps to try and target problems in meta-science. Communities are springing up with the idea that there are problems and that experimentation is needed to fix them. And all the way from policymakers down to grad students, you're seeing incentives, an understanding that incentives need to change to continue making science better. So with that being said, a rare point in time where change actually can be made. And that's something that makes me very optimistic about the future of research, about the replication crisis, about link rot and content drift, some of the problems that are out there. Ricardo? Thank you. So circling back to one of the things I was talking about just a second ago, science itself is a lot more than just a PDF. There's code, there's data, videos, presentations, supplementary artifacts. If we really want to go into it, there's sense-making data. And that's a very interesting question, as I think it was one that Jessica mentioned earlier. Where do you draw the line between commentary and peer review? But part of the answer is probably that you need both of them attached to the scientific record itself. So in one of the previous slides, I mentioned the fact that the current unit of knowledge is a solitary PDF. That unit of knowledge needs to change. And we at DeSci Labs see that as a research object. Ricardo? There are a wide variety of research objects actually being created in the wild. One of the more prominent places that you see this is in the personal websites of individual researchers, where they will post the preprints from their work itself. They will post different iterations of the actual papers. They will go in and post code, explainers, they'll post data sets themselves and store them in servers underneath their desks, because the infrastructure that is provided to them by the scientific enterprise is insufficient to actually handle a lot of that information. Then we also see community developments, platforms like OSF, like ResearchHub, like Hugging Face, which have had a massive impact on how we perform science, but have yet to be integrated. Then we also see changes popping up in the wild around the way that we validate and curate information, with an understanding that peer review itself has problems. One of the more prominent versions of this curation and validation is attestations and badges, which you can see them in the ACM. I believe the OSF has them as well. eLife has been playing around with them. But the idea is that for smaller aspects of what's needed from a research artifact, you can put a true-false statement on that. You can say, is the data for this paper open? True, false. Yes. Is the data for this paper available? True, false. Yes. Does this paper have high quality metadata? True, false. Yes. I understand that high quality is a little bit of a triggering statement there. We'll get to that later on. But the important thing is that you see a need for change from a wide base of users who are looking to make improvements of their own accord. Ricardo? We can move from the static PDF to integrated publications where code and data work seamlessly together to show what the scientific record can be. We can move past some of the proprietary silos of publishers. We can move into a world where machines are equal citizens on the scientific record, where they can more efficiently help us build what needs to be built. And we can create a series of verifiable attestations that can make searching and crawling for quality information significantly easier. So with that being said, that's the context and the background. I'll quickly jump into the technology overview on the next slide. If we can go one after. Thank you, thank you. So DeSci Nodes makes two things, or DeSci Labs makes two things. We make an application and we make protocols. So the application layer itself is what we call a research object or a DeSci node. The idea behind DeSci nodes is that we can create an integrated authoring environment, which allows dynamic contributions. It allows for version histories. It allows for the Git primitive to be applied to scientific knowledge and scientific artifacts. We can create interfaces where peer review and reproducibility checks can be built straight into the PDF itself. We can put more of a granular focus on how reproducibility functions with respect to a paper, and actually storing outputs through a Jupyter notebook, which on the same window as the PDF can be viewed. Our goal is to do this without taking a researcher out of the original environment that they're used to, which is the PDF. A lot of benefits to the PDF. So from there, that application layer is supported by the next slide, which is the data layer. For the data layer, and I'll go through this one a little bit more in depth, the DPID protocol is the center of the work that DeSci Labs does. We believe that an upgrade to DOI infrastructure is going to be critical for science over the next decade to be able to account for the explosion of data, of artifacts, of supplementary information, of sense-making, because you need infrastructure that can handle that explosion. So we start off at the bottom in the gray box by anchoring a root hash on-chain through the DPID registry. On-chain at this moment means optimism through Ethereum, but we're looking to expand that past any single one, L1 or L2, to make it multi-chain so that the entirety of the Web3 world can help secure the PID infrastructure of science. From that DPID registry, whenever a user navigates to the URL that's pinned on chain, what that takes them to is the metadata manifest file for a specific node. That manifest file, both human and machine readable, go into that in just a little bit, takes someone to the root DAG folder, which can then let them expand to any of the subfolders and files within a research object. Not only is this secure and decentralized, but it's dynamic and versionable. We can have versionability and immutability in the same place thanks to blockchain. And I get asked the question quite a bit, why blockchain? Why does it have to be blockchain? This would be the answer. It's because we can square a famous computer science problem. We can solve it. It's squaring Zuko's triangle. Beyond that, we can allow programmable permissions on the scientific record, where even across version histories, we can let individuals be admins, but additionally, let them choose what's seen and what's not seen, who has access to the encrypted data, which, let's say it's a part of intellectual property. There should be specific people who have it and specific people who don't, but for their place as a researcher, they still need for their work to be seen as reproducible. Could be a great example of why that's useful. But just to reiterate, the DPID protocol is the center of kind of what we're building at DeSci Labs. Then to the next slide, there are a couple other aspects of the tech stack which are interesting and worth noting. The DPID layer is the one that I just went over. Would also love to give a shout out to Bacalhau. It's a group that does orchestration for edge computing. So I think it's the opinion of DeSci Labs that data can be viewed as the most important artifact type on the scientific record. Data storage is cheap. Data storage increases exponentially. Moving data is expensive. And the world's networking infrastructure has not kept pace with the growth of the world's data generation and storage. Edge computing as a part of data reuse for scientific work is going to be very important. And Bacalhau is an interesting project that I would encourage you to look into that helps organize compute requests through a variety of different ways. Then below that, for the data and networking layer, we use IPFS as a way to eliminate link rot, eliminate content drift, there we go, and mitigate the effects of link rot. It also allows for some of the versionability that we have and ties into blockchain very nicely as a part of a larger Web3 stack. And for the next slide, all of this technology comes together to give some interesting potential capabilities for any given researcher. So first off, a DPID is an API. So someone can come in, use the DPID, let's say DPID /42, to immediately resolve to the data that's there over HTTP. They can also immediately resolve to the metadata that's there through the API. So if you'll see on the second orange line in the first box, dpid.org /42 JSON LD. That attribute tells the API to surface the metadata for this specific research object. We actually surface it in both JSON and JSON LD for anyone who's curious. But as you see data publishing becoming more prevalent, the importance of metadata is additionally going to become more prevalent. And the importance of search engine optimization on metadata going to be a huge way that people work towards citations, impact, and metrics. So having metadata that can be easily surfaced in a standardized manner, very important part of any publishing protocol, and we believe that the PID is the right place to do that. Our PIDs serve as addresses for edge compute. So at this moment, it's CIDs off of the IPFS network, but we're working to make sure that through Bacalhau, someone can send a compute job directly to a PID. PIDs as APIs allow information to be importable. So we made a Python library called DeSci Fetch, where someone can query data directly from the scientific record into their IDE. So imagine if you could say from DOI.123, import data, and it just immediately showed up in Python formatted as a pandas data frame. That's exactly what DeSci Fetch does. And it also allows you to import functions. Anything that's queryable through that API can be imported. And then finally, as a target for attestations. And I think this is probably, I'll go into attestations in the next section. So what I want to really emphasize is that these DeSci nodes and the DPID protocol allows for interoperability, persistence without social contracts, convenience for users and better user interfaces, and pluralistic governance of the scientific record. So for slide 17, the last thing that I want to talk about as a part of this presentation is credentials, because that's one of the things that's immediately coming up on our roadmap. So we take the stance within Web3 that pluralism is a very interesting way to go about identifying individuals. Attestations are something that we've been a fan of for quite a while. So the idea that you can have one of these small true, false binary statements around a specific research object. So you can say, yes, this research object has open data, or yes, this research object is reproducible. Now, yes, this research object has open data. That might be a little bit more cut and dry. Yes, this research object is reproducible. Well, that depends on what your hardware looks like. For example, I might be able to reproduce code created in Python 2 if I have an AMD processor, but I can't do it on ARM. I can't remember if I got that switched up, but the point remains. It's important to realize that some of this is subjective person by person. So while one group, let's say ResearchHub, is able to reproduce it because they ran it on an older machine as it's an older piece of software, let's say another group, one of the PCCs, was not able to reproduce it and marked it as no. Then all of a sudden it becomes a question for the user of, do they believe that this is reproducible? What comments are in place to showcase the fact that this is reproducible? One of the interesting things about the DPID protocol is the fact that it is open. So if ResearchHub were to want to take comments from their platform as a portion of sense-making data on a paper, take a discussion around how someone reproduced a specific piece of work and add that straight to the DPID with all of the benefits listed above, that would be possible. It allows for all of this information to be portable across platforms, which is huge. We believe that this idea of plural sense making is the right way to move forward without, I guess, putting a single source of truth or a series of gatekeepers in place. Ultimately, it's up to the user to figure out what makes sense for them and to continue contributing to the larger dialogue. Then in the next slide, we see, my battery is dying. That is not what you want. In the next slide, we see the idea of Ricardo. There you go. In the next slide, we see the idea of decentralized societies. So one of the things we're working towards is the idea that any given research institution or I guess decentralized curation community can have their own DPID prefix that they own and control and host of their own accord and can publish versionable, persistent, and immutable research objects directly from that. We want to make sure that the proper branding is in place, that identity and access management is handled correctly. And we're building a product in the not too distant future called Gateways, which is focused on exactly that. And at this phase, it's something that we're still ideating around and that we would love help from the larger community trying to figure out. What is the right flow for attestations? What are the needs of a community as they work to curate this information? I mean, all of these are things that we would just appreciate the chance to discuss further. So if anyone's interested, please feel free to reach out to me about that. And with that, I'll go ahead and say thank you and open it up for questions. Give a big shout out to Ricardo for being on top of it with the slides. Thank you for that. And yeah, I'm excited to hear what y'all think.
Thank you, Eric. Wonderful talk. Making it fit in with the technical difficulty. Well done.
You do what you got to do.
So I have a quick question. if I can.
Sure.
I wanted, so this year, when we were thinking about SciCon this year, something that we really wanted to do is, and we tried to do, I don't know if we achieved it, but we definitely tried. We wanted to, again, bring together TradSci and DeSci, and we wanted to show, how DeSci is helping, fixing the problems of science. And so something that is really close to me is like, how can we show to traditional scientists that these things actually work? What are some of your experiences? Like, have you tried to speak, to TradSci people? How did you speak to them? What are some of the success stories of DeSci labs in trying to implement nodes into like something that has been, currently used to publish? Like, just like tell me what was the experience of like talking to, scientists and researchers?
Absolutely. So I'll start off with two just kind of general statements. First off, a lot of researchers realize that there are problems in the current system. I think peer review would be a great example. People understand that it is political, that it doesn't necessarily always surface the best research, but I think another thing to point out is that scientists by nature are trained to ask why, to break things and to try and put them back together. So we've actually had a lot of success by talking about the problems and by listening to the solutions of individual researchers. So I think I just finished with this particular project about 3 weeks ago. There was a researcher out of Columbia who worked in fluid dynamics at the intersection of fluids and environmental engineering. And he had created a 0.5 petabyte of data, which was essentially a cubic centimeter scale wind turbulence across simulated versions of New York City. Tens of millions of hours on the Stampede 2 supercomputer, maxing out his lab's internal JBOD, all for one single paper. We talked to him. We said, hey, might be cool if we could share this, might be cool if we could do something with it. And over the course of a week or two, about 3 or 4, we figured out, yes, there are different ways that we can share this data. First off, we can get the synthesized version of it. So taking it from that 0.5 petabyte down to 0.5 terabyte and actually posting that through DeSci nodes. Then in addition to that, we'll find the most important dimension for your research, and we'll work to help you get that stored in a way that works for your lab. I think that's a huge success. Then another just final closing point is that I think a lot of folks in the publishing industry specifically, and the funding agencies are seeing some of the policy statements coming down the pipeline and understand that something is going to have to change and kind of see a need to innovate. So that's been another interesting angle to kind of work towards. But with all that being said, does that answer the question?
Yeah, absolutely. And I'm happy to see, to hear that you had a success story already. I know how difficult it is to try and transmit all of this passion and this technological breakthroughs to the traditional science world. So yeah, just really happy that you have a success story already, and looking forward actually to learn more about this, because I'm really curious about this particular story. But in general, I mean, amazing job. Big fan of nodes. So hopefully we hear many more success stories in the future.
Absolutely. I'll tell you, the one thing I think I might be the most excited about for that particular node, we got in early enough with this particular researcher that started off with the original preprint that got sent to the journal. At that point, he had 0.25 petabyte of data. And then it went through peer review, and the folks doing the peer review said, actually, can you double the amount that you have and rewrite the paper? We're going to get that second version as well. And then the final manuscript is going to be published open access on a very permissible license. So we may be able to see from version 1 to version 2 to version 3, the growth of not only the manuscript, but the code underpinning that research itself. I think that's going to be a wonderful example of a dynamic research object and a piece of knowledge growing over time. So it'll be excited. I'll definitely make sure to follow up with you on that, Ricardo.
Yeah, definitely. I mean, that's exactly how, open source or like software works, versioning and so on, kind of like,
Yeah.
So yeah, definitely exciting.
Well, I think we can close it here. Thank you very much, Eric. As I said, well done. I'll head off and hand it over to Ricardo.
Thank you, Eric. Thank you again for coming.